All right. Good morning, good afternoon, good evening, wherever you are in the world, and welcome to our PolarConnect event. I'm Janet, and Sarah is standing by somewhere in Denali, and I'm in Fairbanks, Alaska. I'm in Anchorage, Alaska, and we are very excited to be here with you on this Sunday with Peggy McNeal and the team that has been in Svalbard, Norway. They're with the High Arctic Change 2014 PolarTREC expedition, which I'm sure a number of you have been following. And today is August 10th, 2014, and we've got a few things we want to cover before we turn it over to Peggy and the team for their presentation. The platform you're using is called Blackboard Collaborate, and the center of the screen, if you're joining us by computer, that is today, it should have changed, and you should be seeing a slide showing some of the features of Blackboard Collaborate. There is a section that has an audio and videos piece to it. We'll have a little bit of videos from Norway. There we go. We see them now, and we got there. And we'll have audio feed, voice over IP. Norway. If you're calling by phone today, we ask you to mute your phones by pressing *6 to mute, and then *6 to unmute when you need to talk. If later on you want to ask some questions live, you can click on the little talk button if you're using voice over IP just below the video feed. You click it once to open up your mic, and then you click it again to close it when you're done. Sarah and I have good control, so if you leave your mic, we will join by phone, and that person that joined by phone, welcome. We would like you to mute your phone, *6 to mute your phone, or use the mute button so we don't get background noise. And then when you have a question, *6 to unmute it, okay?
Okay.
Okay. You can also see a list of participants, and then there is a little chat box. You can type your questions in the chat box or say hello like some people are doing already. Just type it in the white area, hit return, and that goes to the whole group. All right. This event is being archived, and we'll post it online when here in a couple of hours or so. Okay. We'd like to have an idea of who is participating. So please type in your name if there's people with you, how many people are with you, and if they're students or adults, just give us an idea of what's going on and give Peggy and the team an idea of who's participating today. So the next little piece is about PolarTREC. So why is Peggy in the Arctic? You might be wondering that if you haven't been following along or had direct communications with her. She's part of a National Science Foundation funded program called PolarTREC, Teachers and Researchers Exploring and Collaborating. We send teachers with researchers like Julie Brigham-Grady and Ross Powell, who you'll be introduced to in a little bit, to the polar regions, the Arctic and the Antarctic. They go there from anywhere from 3 to 6 weeks or so, and they learn about science that is happening in the polar regions. We've been doing this for a while, and we've placed over 100 teachers in the polar regions since 2004. We hope to keep doing it. It's a great program, and the teachers get a lot out of it, and they take it back to their classrooms. A quick thing about questions, if you might have missed my intro, if you have a question during the presentation, in the chat box, and at the presentation we have live questions by phone or computer. Just raise your hand by clicking on the hand icon above your name, and we'll call on you. And then again, you click once on the talk button to open up the mic, and click it again to close it. And if you're by phone, you'll unmute your phone. And I think that's it. Sarah, did I miss anything?
No, I just do want to mention to folks, it looks like people are sharing where they are coming from and who they're with, but they're doing that in individual chat boxes. The easiest way for everyone to see what you are saying is to use the Room tab. It's the far left tab under the chat box. It's the first one on the left. And so if you type in there, other people will also be able to see what you are writing. In case you have a question or something like that, people will be able to see your questions or comments. So it's on the far left. You don't have to start your own chat.
Oh yeah, I see that. I just caught up with that too. So yeah, so there's a couple people that are just keep posting there. So guys, just go to the main room so that everybody can see it, because it will be really hard for the team to keep track of what's going on. So post in the main room and then everybody will see it. All right, with that, we're going to turn this over to Peggy and go ahead.
Hello, hello, can you hear me?
Yeah.
And is there any feedback?
Yes, this is Sarah. Folks on the phone need to mute their phone, press star.
I don't know how.
On your keypad for your phone, there's a little star symbol probably in the bottom left. Press that and then press the 6. And that should work. Okay, Peggy, go ahead and speak again.
Okay, I'm talking now. Can you hear me without feedback?
Sounds better.
Are we ready then?
I think so. I think it sounds all right.
All right, and I'm loud enough?
I believe so. Folks, if you have any trouble hearing her, in the room chat box, you can say yes or no if you can hear her well. In the far left chat box.
Okay, then let's get started. So first of all, welcome. We're so excited to have all of you here, and we're really happy to be able to share our science and our adventure. And we've been looking forward to this all week. I want to let you know a little bit about our setup. There are 9 of us here, and like Sarah and Janet have been saying, we have 2 computers set up. So I'm on one doing the talking and moving the slides, but I have my whole team here with me to answer your questions. So for sure, we're going to have questions and answers at the end. But if you have questions that pop up while I'm talking, just go ahead and type them into the chat room, and I've got my team here ready to respond. So use that, please. So the plan for tonight is we're going to go over a little bit about an area of science that you probably haven't given much thought to, maybe never even heard about, glaciology, the study of glaciers. So we're going to share that and our research, a little bit about what we've been doing, and then our life here in Neelisand, what it's like, some of the things that we've seen, and some of the fun that we've been having. But first off, you're looking at a picture of seagulls. And you might be thinking, well, what is that? That's not very exotic. We all seen seagulls. They're all over the beach and anywhere that there is water. But these are kind of special seagulls because they're glaucous gulls and they only live in the Arctic. And we've been seeing them around on the water every day when we go out. They make really funny noises and keep us entertained. But what you're looking at is just a small portion of the big picture. So here is the big picture, and now you can see the little seagull just at the very tip of the iceberg. And so that is an iceberg that we saw that I got a picture of, and there's hundreds of them out there on the water. And we pass them every day and check them out and just stand in awe and stare at them. In fact, today, all of the REU students got out and climbed up on an iceberg. And while they were there, they made snowmen and snow angels. It was a very safe iceberg, so it was a lot of fun. And collected samples. But the reason I'm showing you this is because I want you to keep in mind that we want to look at the big picture. And I'll bring that up a little bit here and there as we're talking but always referring back to the big picture. So let me go ahead and introduce our team. From the upper left-hand corner going clockwise, we've got a lead scientist, Ross, and then we have REU students Steve, Jessica, Kane, and Ryan. Bottom right is our lead scientist, Julie, and then me, a PolarTREC teacher, Peggy, and two more students, Dominique and Courtney. And if you're wondering why Steve doesn't match the rest of us, it's because he's 6'8", and so he needed a special survival suit, so he gets special colors as well. Anyway, all of these students have been selected to participate in this research experience for undergraduates, and they're each taking one aspect of the research and working completely on that, and then we'll bring it all together, but when they go back to their schools, they'll write a senior thesis out of the research that we do here. So it's very neat, and they're a lot of fun, and I feel very fortunate to be with a team with a bunch of 20-year-olds. So this is our glacier, really. This is what we're studying, the Kronbreen Glacier Complex. It's quite beautiful. And you might be wondering, well, why that glacier? Why are you interested in that glacier? Why is anybody interested in glaciers? Why is anybody studying glaciology? But again, you have to think about the big picture. So when we study one glacier, that informs us about glaciers as a whole. It informs the science of glaciology, and also how glaciers fit into Earth's systems and our planet and the way that our planet is changing. So particularly in this area of the world, we're looking at how warm North Atlantic waters are moving into this part of Earth and changing the glacier system. So let me orient you to our glacier. This is a 1990 aerial photo of the glacier that we're studying. So it's kind of labeled up for you, but let me go over it. Kronbreen is the main glacier that we're studying, and it merges on the top with Kongsviken. Now glaciers are like rivers of ice. They do flow, of course, much more slowly. And as they do that, they act like giant bulldozers, scraping up bedrock and pushing it to the sides and in front of them. And in the case of tidewater glaciers, which end in a body of water, they push them up in front and then empty them into the water. So those are the two glaciers in the system that we're looking at. To the bottom of that is an island that's going to come in here in just a minute, so keep that in mind. What's really obvious in the water looks like a big muddy puddle, and that is sediment that's being deposited into the water. On the upper shore, there is a delta. There's a meltwater stream that's flowing along the top edge and depositing sediment also into the water. And so you can see a delta building up there. And then up to the right, upper right-hand corner, there are some valley glaciers that are also descending down from the mountains. So same slide now. And on this one, I have marked some changes for you. So the red line is where the glacier has retreated. That is where it is now, where it has retreated to when we showed up. The green line indicates the fact that Kongsviken, the upper glacier, is really kind of getting squished out of the way, and Kronbreen is pretty much just taken over. And what's really interesting is that big muddy spot in the middle isn't there anymore, or at least isn't there in that spot and isn't that big. So those are the changes that we noticed when we got here right away. Now, I want to present the latest and greatest brand new data, hot off the press. This is what some of our students put together, and this shows some additional data on the same glacier system. Now I have to reorient you because this is totally flipped around. So now we're looking from a different angle, and the island is at the top. So you can see Kronbreen and Kongsvegen down in the bottom right. And the fjord, so the body of water is called a fjord. It's a glacier-carved bay, is Kongsfjord. So there's a lot of little numbers and lines on there. So the gray and the green and the pink and the black lines show you where the glacier was at the different dates that are written next to them. But what's really cool is you see all those blue squiggly lines? That's where our boats have been going, and that's where we've been mapping the bottom of the fjord and collecting data. And so you can see that we've been driving our boats in an area that was once covered by the glacier. So it's pretty cool because we're doing research on an area now that was underneath the fjord and underneath the glacier. And so this is brand new data on an area that has been recently revealed by the glacial retreat. So, oh, we're missing a slide. That's okay. Oh wait, it's way down here. Can I skip over a bunch of slides and come back?
Yes, you definitely can.
Okay, so here we go. All right, so this is a picture then that shows just basically a generic glacier. And what's really cool is that glaciers aren't just solid masses of ice, but that they actually have liquid water channels in and under them. So they basically have plumbing systems. And that's what we have detected has changed drastically. And so that is why that big muddy puddle isn't there anymore. And it's called a sediment plume, and it's changed. It's changed where it is, which indicates that the plumbing underneath and in the glacier has changed as well. So that's what we're trying to understand, and that's what we're trying to understand to know what has changed and how it has changed and the dynamics behind that and what's caused those changes. So we've been looking at the glacier and trying to see what's going on, and we have some hints. So here are our hints. First of all, in the southeastern corner of the glacier, it's relatively open. There's no ice there, usually, depending on how the wind goes. But for the most part, it's the most open part of the glacier or the fjord, and the rest of it is somewhat choked with ice. And so what we think is that there is a current there. In fact, we've measured, and there is a current there that's pushing out the ice. So perhaps the new plumbing is in that area of the glacier, and that's where we're getting some discharge from a subglacial stream. The next thing that we've noticed is this. There's ice caves. Well, I have to say there was. Today when we were out there, that whole arch over top collapsed, and it caused a huge calving event and a big wave. It was very, very cool. But anyway, when we see those ice caves, that's another indication that there was a former subglacial channel there and that the plumbing, again, has changed. Now, if we zoom in on that, whenever we look in that cave, there's lots of birds flying around. They seem to love it there. Obviously, there's something attracting it. And so most likely there's some type of upwelling coming from underneath the ice there in the water and bringing up nutrients. Now, when these subglacial channels exit the ice front, they are very buoyant because the glacier itself, of course, is freshwater, and so it's not as dense, so it rises to the top, whereas the fjord has salt water. So that's kind of another clue that we've been looking at. All right, here's something that's really cool. This is a grounding.
Peggy, really quick.
Yes.
Just a really quick interruption. Oh, looks like Julie answered a question we had in the chat box for folks on the phone. Somebody was asking, how old are the glaciers that you're studying? And Julie Brigham-Grady answered, the glacier is a remnant of the ice from the last glaciation about 20,000 years ago. Just wanted to relay that to folks who may be out on the phone.
Okay. Thank you. So back to our grounding line deposit. So if you look at this picture, see kind of how in the middle you can see like a little bit of dirt, and then like there's a whole bunch of ice chunks that are kind of like caught up on it. Basically what has happened in this area, and it's the same area as the other pictures, is that there's so much sedimentation that it has built up from the bottom of the fjord, and now it's surfacing above the water line. So that, again, is a huge indication that we're getting a lot of sediment deposit there, and that, that there's some type of a channel exiting from that area. So King got out and looked around and walked on it, which is totally awesome, because that is probably, I mean, he's like the first person to ever walk on that section of Earth, and so we named it Caneland. So he got out, and later some other students got out, and they walked around, and they were looking at the sediment there and noticing things like most of the rocks are rounded, which is an indicator of water erosion, and that they're different sizes, that they're poorly sorted, which means, again, that it was carried by some rather high velocity water. And so that is a really clear indicator that we have a subglacial channel that is depositing and causing that type of buildup. So that's super cool to be able to kind of walk on a spot of Earth that has never been walked of before and look at the clues there and be able to decipher what is going on there behind the glacier. So those are the kinds of things that we're looking at. And now I have each of the students have prepared a slide for you, and they're going to get on one at a time and make what we're calling a little tweet, which is a 1 or 2 sentence synopsis of who they are and what they're doing. They won't be able to go over all of the information on their beautifully prepared slides, but we'll leave it up there long enough that you can scan it and look at the pictures. And of course, if you want to delve deeper, then you can go into the archives and look at their slides in more detail then. So first up, and are we going to, yes?
Hold on, Peggy. Hold on. First things, a few things. If the next group could slow it down, I know you're excited, but you were talking about 100 miles an hour, Peggy. That was the fastest presentation I think I've ever heard. And two, there's some questions, so don't go away. Somebody wanted to know, isn't walking there dangerous underneath that all that ice? Is there potential for ice falls? And Julie did answer, but go ahead and you can respond.
Okay. Well, what she's saying is, okay, one thing is, when we take these pictures, you lose depth perception because the glacier behind you is so huge. So when you see pictures of our boats or people next to the ice, they are not nearly as close as they appear to be. And then of course we have, telephoto lenses that we use so that we can zoom in and get these awesome looking pictures. So no danger. He's about 4 football fields from the ice there. So we felt very safe having them there. Was there
okay, and yeah, there's another question. Lucy Coleman wanted to know how much you need to worry about the birds when you're in the boat.
Near the boat, same thing. Oh, the icebergs. We have these great little boats that luckily are really strong, and they're designed and built to kind of, they're not ice cutters, they're more like ice pushers. But luckily, they can withstand banging into ice because, as all of the students will testify, I do quite a bit of ice banging. So, yeah, if it's a really huge one, Lucy, we go way around it. And the little ones we can bump into, and they kind of push out of the way, and it's not a problem. Any other questions that I'm missing here?
I think you've got it. I don't see any other. Oh, wait. Bill asked, how long will the ground there persist? Will it erode quickly?
How long will the grounding deposit persist, and will it erode quickly? Well, Julie's typing away. She's going to answer that question. But while she does, I'll give you my thoughts, which is, it's a dynamic between how much the water is eroding it versus how much it's building up, and whichever one is the stronger of the two forces will depend on whether it continues to build or whether it erodes. So Julie's working on that.
Okay.
Some more questions are popping up.
Yep, another one from Dr. Wiley. Have you been able to determine how quickly the rate of calving has changed in the time you've been researching? Are they changing quickly?
Well, hello, Dr.
There's
Wiley.
lots more.
Dr. Wiley's my brother-in-law. Julie's, again, typing away and trying to keep up with all of the questions. In past years, and I know Dr. Wiley, I told you about this. We used an instrument, they used an instrument called a hobo that measures pressure at depth, and that can get the rate of calving. The students choose their research topics, and nobody chose that specific topic, so we're not using the hobo this year. But perhaps Julie can just, and Ross can just give us a general feel for the calving rate and if that has increased as well. Did you type that in?
Yeah, let's have Julie talk, because there's people that are on the phone and that might not necessarily see what is happening in the chat area. So Julie, respond to some of those questions about the fjord, the source of the buildup, calving, and all that kind of stuff. Go ahead.
Okay, so do you want me to continue to talk or wait for her to catch up on the chat?
If Julie can catch up, that would be great. Can she talk?
Yeah.
Relay the question.
Do you want to just talk and answer the question?
I can, but I thought we were pressing.
Okay, she's coming on over here to answer some of the questions. And is the first question about the calving rate?
Yep, I will relay them to her. So the first one is how quickly the rate of calving has changed in the time that you've been researching. Are they changing quickly?
Well, we've only been here just 2 weeks, so we haven't seen a particular change in the rate, but the glacier itself is moving forward into the fjord at about 2 meters a day along its entire margin. So we see quite a bit of calving all day long, particularly later in the afternoons, but we can't really say whether that rate is faster or slower than before we arrived. But I think if you can just imagine a wall of ice about 3 kilometers wide moving forward about 2 meters a day, that gives you an idea of the calving rate.
Okay, and I just got to say that I was reading the chat there, and there was some clarification about the term calving, not meaning like little baby cows are being born everywhere. That's a term used in geology and glaciology about the ice falling off of the front of a glacier.
That's right. It's the term for the icebergs being produced by the ice falling into the sea. The fjord floor in front of the ice varies a lot in depth, from anywhere from 20 to 30 meters to as much as 70 to 80 meters right at the ice front. In many areas we're working, the depth of the fjord can be as much as 100 meters deep, but most of where we're working is 100 meters or less.
Okay, and then there was one additional question about where is the source of the buildup? Somebody came in late, so I'm not really sure what buildup they were talking about.
Perhaps that means the source of the ice that's flowing to the sea? Where is the source? Oh, okay, so Peggy mentioned that the glacier has a plumbing system. So this Kane's Land, as we call it, was built when the ice was in a slightly more forward position next to where that feature was formed. It initially formed from sediment from under the glacier coming through what we call subglacial conduit, a tunnel system. It's delivering sand and gravel as a little sediment fan on the seafloor, and then as it builds up over time, it can become emergent at the surface. So we, as geologists, we call them subaqueous fans or underwater fans, and then eventually they can become these delta surfaces as we see what Kane's walking on in the picture.
Okay, I think we've caught up with the questions, so thanks. And yeah, I guess now we're ready for the tweets from the students.
Okay. So, presenting our students then. Here is our first slide. And are we going to have their faces on the video? We can't because they have to come over here to talk.
No, they're right here, and then we'll hit the top.
Okay, so first up we have Courtney Payne. She's going to talk about her research into biological oceanography, and then we'll move on to the next student. So here we go.
I'm not sure if you can hear me, but I'm studying how the glaciers retreat is causing changes to the biological communities that live nearby.
Okay.
Hi, my name is Kane. I'm studying the depth of the water right near the base of the glacier, so I'm going around and mapping the various depths, and eventually will result in a map as you see in the lower right-hand corner.
Hello, I'm Steve, and I'm working to determine sedimentation and accumulation rates and answer other geologic questions based on sediment produced by the glacier.
Hi, I'm Jessica, and I'm looking at strontium and neodymium isotopes to track how the bedrock in and around the glacier changes over time.
Hello, I'm Dominique, and I'm studying how that plumbing system that Peggy was talking about is changing. So looking at where the upwelling is occurring and how those characteristics are different from what we've observed in previous years.
Hi, I'm Ryan, and I measure salinity and temperature to understand the interaction between Atlantic waters and waters that come from the freshwater glaciers.
All right, so can I go back? All right, aren't they great? So that's our team. And one thing that's really important that I want you to know is even though they each talked about their own individual projects, they're very collaborative. And they share data. They have to share data because they need each other's data in order to complete their individual projects. So we take 3 boats out into the fjord every day, and they hop aboard with their instruments, and we take them where they need to go to get their measurements, and we come back to the lab. They download the data. They share with each other. And go from there. So we're learning a lot, uncovering a lot of new ground, and doing a lot of really neat things. I have to also tell you about our lead scientists. So we have Dr. Julie Brigham-Gritty and Dr. Ross Powell. You've seen Julie. I don't know if Ross wants to stick his face in there and say hello. But they have decades of experience in geology and glaciology, and have been working in this area since 2005. And they have, this is their 4th group of students that they've brought to Neelisand. And so they just do a great job. They're great leaders, great scientists, great people. All right, everybody always wants to know about animals, so we'll talk a little bit about them. Believe it or not, and this is quite unusual, we've spotted polar bear twice. And once was right outside of the dorm, and that picture in the upper left-hand corner was taken by Julie. And it's somewhat famous here at the Science Research Station. They have it up on the bulletin boards, and she just got a really great shot. The second polar bear sighting was actually when we were on the boats out on the ice. And that was very exciting and kind of cool. And but we don't have any pictures because we were moving out of the way and letting the polar bear be a polar bear and do his thing. So both of those are really exciting and give us lots to talk about. Moving over one picture, we have the Black Diamont. That is a very cute little bird that we see in the fjord all of the time. The funny thing is you try to go get its picture and then it dives under the water and you just don't see them again. They just poof, disappear. Next to that are the seal, which are very cute, and of course they are the polar bear's lunch. We spotted several of them. They come out and have or lay on the icebergs, and they're very neat to see as well. Bottom right-hand corner is a barnacle goose. The area around the science station is actually a bird sanctuary, so we can't walk just across the grass. We have to stay on the sidewalks. Because these guys are all around with their young chicks and doing their bird thing. So they're really fun to watch. Middle picture is the only one that one of us didn't take ourselves. But that is an Arctic fox. And we've seen several of them scampering around here. They're very cute and they look like they're playing, but they're actually eating the bird's eggs, which is kind of sad. And then finally, a snow bunting in the toilet. So we were on our way to the target range and our instructor stopped us at an outhouse on the bridge and told us to follow him, and we weren't sure what was happening, but when we went inside, sure enough, there was this little bird that had made its nest inside of the toilet. The toilet goes straight down. It's on a bridge, so everything just kind of drops into the air and down below the bridge. So that's why the bird is able to make a nest in there, because there really isn't anything in there. So those are the animals. So here's just some more pictures of us doing our thing inside of the lab and out. Kane and Steve are working on some of their sediment cores there. Next picture over upper right, Dominique is being assisted by Courtney and Jessica that are holding on tight so that she can get some measurements on the cusps in that iceberg. And we all have to help each other in the boats, bring up the CTDs and the core samples. They're quite heavy. And so there's a lot of teamwork, a lot of collaboration. We really have to rely on each other. And then in addition to our team, there are scientists here from all over the world. So it really is an international environment, an international science station with people doing all kinds of fascinating work. We all eat all of our meals together in a dining hall. So that's a great opportunity to talk to people from all different countries and to meet new friends and new people. And it's just been a really, really great experience. So that's us. And I want to make sure that all of you stay tuned because we're really only about halfway through our research. The students are continuing to collect data. We go out in the boats how many days have we done it in a row now? 6, 7? So we go out in the boats every single day. There's that much work, that much data collection to be done, and we'll continue to do it for the rest of the time we're here, which is another week. So there's lots more to learn and to discover. So stay connected to the journal so that you can be part of the science and part of the adventure for the rest of the time. And that is what I've got. Now we can take it if anybody has any other questions.
Yeah, so I put up the question slide, and if you're on the phone, just let us know if you have a question. But if you click on the little hand icon above the list of participants, we can call on you so you can ask your question live. While you're thinking about that and doing that, somebody did ask a question. Richard wants to know, did anyone get seasick?
Does anybody get seasick? Do you guys feel seasick? No. The boats do rock a little bit, but it doesn't seem to be a problem. I don't feel sick at all, but I will tell you, it's not happening so much anymore, but the first couple nights after the first days in the boat, when I laid down in my bed, I just felt like I was still rocking. So there's that, but none of us get seasick. And I see Tom and Lillian are asking about the weather. Hi, Tom and Lillian. It's hovered around 4 or 5 degrees Celsius, which is somewhere high 30s, low 40s. When we first got here, it was blue skies, clear, absolutely beautiful. We had a little bit of sideways blowing snow one day, and that was a little frigid. And since then, it's been calm weather, but with a pretty significant cloud layer, which is nice because we can get out there and get our work done. It hasn't been too windy. So other questions?
Okay, and then there was a question. Let's see. Art and Deb would like to know, how can you tell when an iceberg is about to calve?
You can't. They're very unpredictable, but when they start going in one area, often it's kind of a domino effect. Additionally, sometimes huge cracks open up. Like today, we were watching that arch, and little
Oops, are you there, Peggy?
bits were dribbling down. It was 5 minutes, then we can go. So we did, and sure enough, the whole arch collapsed just then. Yes, can you hear me? All right, what should I repeat?
Yes, it can. You cut out there for just a moment, so we heard you again. We hear you again.
Okay.
Are you there, Peggy?
And then I think Julie wants to say something.
Yeah, about the ice calving. Yeah?
Can you hear us?
Let me go to the other.
Yes. We hear you. Yes.
Okay. Do you want to talk? Do you want to come over here? All right, Julie's going to address the calving question.
I just wanted to add that we have very strong protocols about how close we are to the ice margin, and we always try to stay, at least 1 to 2 football field lengths away from the ice. So if people know how long a football field is, they know that we're 2 or 3 times farther than that from the ice margin. So there's really we watch the calving events like you would watch fireworks going off. It's lots of fun.
Okay, and we have a question for Peggy that was a little bit somewhere after the fishing question, which was, what has surprised you the most about your expedition so far?
What has surprised me the most? I think that we actually saw polar bears. When I was talking to groups and to kids, there's this huge interest in polar bears. And everybody, would ask about that. And in the back of my mind, I was thinking, this is great. They're all excited, but I really doubt that we're going to see one. And then to see 2 is just really, really lucky and unusual. I guess the other thing would be, I knew this was going to be an amazing experience, but it's just been like so over the top incredible, and I'm just having so much fun. So have to add that. All right, other questions?
Okay, Peggy. Peggy, I'm going to ask you to turn off your mic for a moment so that Bobby can ask his questions. Okay, Bobby, go ahead. Click on the top.
Can you guys hear me? Have you guys interacted with any Svalbard locals? And if so, what do they do for work, or what is their culture like?
Hi, Bobby. We were just talking about that today. Svalbard is pretty remote. The settlements are pretty small. It's great now that we have sunlight all of the time, but it's got to be pretty grim when it's night all of the time, and additionally it's pretty cold. So we were talking today about whether or not we think that anybody ever really lived their whole life out here. And if you would ask somebody from Norway, where are you from, if anybody would ever say, well, I'm from Svalbard. I think that that would be unusual. Certainly it's probably happened. In fact, there was a group of people here that were children when this was a coal mining area, and they lived here as families of the coal miners, and they got together, and I believe they have a museum that they run, so that's kind of neat. Other than that, most people will come here maybe to work at the science station or to work in the main city, Longyearbyen, but and there's a school there, but most of them are from the mainland and don't spend their entire life living here. Thanks for the question, Bobby.
Okay, and there's a bunch of questions that have been coming to Julie and Ross about the changes, and I saw Julie's been answering to some of them. So maybe if Julie can recap for those of us that haven't been following on the chat as much, can you recap what you've been responding to, Julie?
Yes, and so can you kind of paraphrase the big question?
Well, there was something. Sorry, I have to go.
Yeah, Jan, I've got there's questions about the biggest changes that Julie and Ross have seen over time, and the greatest potential long-term benefit of research. And then, sort of, how far back does the data go, and what are we seeing for recession of glaciers, I believe.
Yeah, this is Ross. So the ice has been retreating ever since we've been looking at it. Sometimes early on, in the early years, it was retreating slowly, but it's starting to retreat very rapidly now. And some of the other measurements that we made are the temperatures of the ocean water in front of the ice. And we've seen those ocean waters warming since we've been working here. And hopefully our data this year will help us understand whether that trend is continuing. And the ice is retreating much more rapidly now, and so perhaps we may find that the water is even warmer. Because what scientists have been finding here and in Greenland and in Antarctica is that the warmer waters coming onto the ice that are being caused by global warming are actually helping to melt the ice fast and make it calve. And so that's what scientists are concerned about, is that the water that is stored in the ice of the glaciers and ice sheets is actually raising sea level, and they're calving and melting even faster now than they have been in the past.
Okay, great. Thank you, Ross. I think we're going to go to a couple of live questions. A couple people have their hands up, so let's go to the Osum family. Go ahead and click on your talk button.
Yes, we were wondering how everyone is enjoying the Norwegian food and if you've had a chance to try lutefisk yet.
All right, Steve is coming over to answer that question.
Mom and Dad, we've all been very pleasantly surprised by the quality of food. We haven't had a disappointment yet. Lutefisk is pretty much just a holiday meal, so it's really not something that they would serve. That's, for those of you who don't know, it's cod that's soaked in lye, which is the main ingredient in soap, and then aged forever. But it's supposed to make you live forever if you eat it, so that's why we do it. But that's just for Christmas. No, we haven't had lutefisk.
Thank you. Okay, the Kraft family has a question. Go ahead, Kraft family.
All right. Hello, everyone. Hello, Peggy. Hello, team. So our question, the question I have for you is, when we met some of your colleagues up at East Fjord Radio, the glacier that they're studying not only is receding, but was kind of deflating, is the way Al described it to us, where not only is it retreating, but the width of it, the height of it is shrinking. Are you seeing the same thing with this glacier?
Hi, Peggy. Can't hit my, there we go. Hello. For everybody, the Craft family is a wonderful family that we actually met when we were in Longyearbyen. Larry contacted me via the blog. His family is traveling the world and blogging about it. And so he contacted me, and the whole team had dinner with him in Longyearbyen. So hi, Jamie. Hi, Jason. And I will put Ross on to answer that question.
Yeah, so it was a bit hard to hear the question, Larry, but I think I understand that you are asking whether the ice is also lowering as well as melting fast in the ocean. Is that right?
They're typing. They're typing, Ross. Yes. Is it deflating?
Yeah, okay. Yes, that is happening too. In fact, on the sides of the mountains, when the ice lowers, it leaves a ridge of all sorts of rocks and debris along the side of the mountain, and you can actually walk up along that moraine ridge up the side of the mountain well above the glacier. As the ice is also lowering and deflating. There's also a lot of melting that is happening on the surface, and the streams that are coming out from the ice are actually evidence of the glacier melting on the surface and lowering itself. And it's also flowing fast, and as the ice flows fast, it sort of stretches out. And as it stretches, it thins. So there's melting on the surface and also the stretching of the glacier as it's flowing fast into the ocean.
Okay, thank you, Ross. And the Craft family says thank you also. There was a question, and maybe Sarah, you were pointing Margaret into someplace, so I'll let you.
Yeah. Margaret's question was about shoreline increase or high tide possibly wearing along shorelines. I mentioned to Margaret that we just had a PolarTREC expedition conclude just yesterday about shoreline shift in Barrow, Alaska, and so I put the link up there. But I think I'm looking down. Looks like Julie's answering a little bit about sea level, and then another question came in about freshwater changing the levels of salinity over time. Does the research team want to just mention any recap of those two together?
I can mention that, you know, as I wrote, globally sea level is going up about 3 millimeters a year, but that's averaged over the entire globe. And many parts of the world are experiencing more rapid sea level rise than others because of various geologic complications and the erodibility of the shoreline and so on. So it's very hard to generalize on that question, but certainly it's very clear that much of the east coast of the United States and certainly parts of the Alaskan Arctic are very vulnerable to sea level rise. Even if it sounds like 3 millimeters a year is not much, it actually adds up over time, and predictions are now in the range of 1 meter to 1.5 meters in the next 80 to 90 years. So it really adds up quickly, and of course we have a lot of infrastructure in the way. So these glaciers are retreating globally, and we need to understand how quickly they will contribute to sea level rise. They are contributing fresh water, but that because the oceans are so large and so mixed, they are not changing the overall salinity of the global ocean. Only locally in the fjord do we see the fresh waters then mixing with the salty waters below. So the mixing process is relatively complete by the time the water gets out into the open ocean at the mouth of the fjord.
Okay, and we want to have Dominique come back to the phone here. There was a question. about what the tools she's using to study the plumbing of the glaciers. I saw that she typed it up, but we'll have her explain out loud.
All right, she's on her way coming over.
All right. What would you like me to explain more?
The plumbing. They just want to know what kind of tools you're using for your work.
Well, as Peggy mentioned before, we're all using different instruments and collecting data, and then we'll be sharing that to get an idea of what's going on. So me specifically, I've been helping one of my teammates, Ryan, with CTD data and collecting information on the temperature, the depth, and the salinity of the water. I've also been, at the same time as we do a cast of the instrument, I've been collecting water samples at different depths to figure out what the concentration of sediments are at different depths in the water, which is then used for water density and figuring out how much sediment is being transported by those subglacial currents. And in addition to that, I've been using drogue data. So what we do is drop the drogue in the water and mark its GPS location, leave it for a while, come back and pick it up and get the new location to figure out how far it's traveled. And what's really neat about the drogue is you can put it in at different depths. So we just attach a rope that's, say, 20 meters long and leave it, and so we know that the water down at 20 meters is moving at a certain speed. Other than that, I've been collecting hill samples off of glaciers that have risen up from the bottom or that have scraped the bottom when they fall off of the face of the glacier to figure out what is in that sediment and what's, if we can trace that to certain areas, and if the sediment that was being deposited in certain areas by plumes from previous years, if we see that moving with the moving plumes.
Okay, great.
Yeah.
So, we have time for a few more questions. A couple came up in the chat. And then let me see what they were here. Margaret said, are you noticing more world precipitation due to increases in available water for evaporation? That's one of them.
On a global scale, if you look at what's been happening over the last few decades, is in general, many of the areas that are receiving more precipitation than they did before. For example, the eastern seaboard and New England is getting warmer and wetter, but at the same time, as we know, the western United States is getting much drier and more drought-ridden. And so often the dry areas are getting drier, and the wetter areas are getting wetter is a good generalization. But the increase in open water, I guess the question is, that's not really a big factor in causing any additional evaporation. So I can't really answer that direct question because the process is not really related to the area of open water.
Are there more questions?
Okay. Really sure it might have had to do with Dominique's drawing or somebody's drawing, but I didn't see that. But Tom and Lillian know that the glaciers are depicted as beasts spewing fresh water. Is there a story behind that? And
Yes, I found these pictures. They're a series of drawings that were done in, I think it was 1911, by an artist depicting some glaciers in the Alps. And at that time, the glaciers were advancing a great deal in these particular valleys. So the artist had drawn the advancing glacier with a face, as if the meltwater was coming out of its mouth. And they're just quite fascinating pieces of art that are just a lot of fun. Of course, the glaciers in the Alps are retreating rapidly today, as they were, as they are globally. So they're just a lot of fun to look at. And if anyone's interested, I can give the address to Peggy, and she can put it up. We can put it up on the blog, so other people can enjoy those pictures.
Okay, and then we have one more question from Margaret, and then I think we'll be done. And if you didn't get to ask your question today, be sure to post it to the team in the Ask the Team section. But Margaret wants to know, as we add frozen water to a closed system, we could be making that system colder. So on a global scale, as we add this iceberg water to the world system, why aren't we having global cooling?
Oh. Yeah, the melting glaciers are, of course, when water melts, it's at 0 degrees centigrade. The water here in the Arctic, I think in the fjord, is what, 3 or 4 degrees. It's not really having a rapid increase on the change of the global water temperatures. What's more important is the greenhouse effect, the increase in greenhouse gases in the atmosphere, which increases the temperature of the surface atmosphere around the globe. And so we have warmer surface temperatures in many parts of the global ocean. So the contribution of glacial ice from both the Arctic and from the Antarctic as well cannot overwhelm the increase in water temperatures that's happening just due to solar radiation and the greenhouse effect.
Okay. Anything else?
Okay. No, I think we're pretty good here. Guys, for all your work, great program, and great presentation. And if you didn't catch it earlier, we are archiving this, and we'll post the archive link on the website, and so you can share it with others. And we do have other PolarConnect events coming up, especially as people start to head towards Antarctica here this fall. So if you're interested in joining us, but anyway, we want to say thank you, everybody, and great job, Peggy and team, and hope you guys have a good rest of your adventure.
Thank you. Thank you, everybody, for coming. It was a lot of fun.